Assalamualaikum and hi, we are from Group 1 here to present our lab report for experiment 6, which is the experiment calibration of Bourdon tube pressure gauge. Here our group member, which is Lim Zi Hui, myself Norainun Basyirah, Nurul Afifah and Afiq Danial.
This is our table of content.
For the introduction, the experiment explored the accuracy pressure reading from a Bourdon tube pressure gauge. The Bourdon tube gauge is used to measure pressure in fluid and it needs to be accurate to provide reliable reading. A dead weight tester is used to apply pressure by adding weight onto a piston. The calibration is the process of comparing the actual pressure by the dead weight tester with the gauge reading to check its accuracy.
So the objective of this experiment is to determine the percentage error of a Bourdon tube pressure gauge using a dead weight for calibration.
So for the theory part, the Bourdon gauge is connected to a deadweight tester. So the Bourdon gauge has a transparent towel that allows students to see the working mechanism. So the mechanism is a thin wall tube with an oval cross-section span into an arc. One end of the tube is held rigidly. This end emits pressure. The other end of the tube connects to a dowel and pointed mechanism is free to move. When the pressure in the tube increases, it tries to straighten and so move the pointer by an amount proportional to the pressure increase. So to calibrate the gauge, weight will add to a platform on a dead weight tester. The weight put a known force onto a piston. The piston has a known area. The pressure actual can calculate it. A flexible tube containing water transfer the pressure on the piston to the bottom tube. The weight added in increment, recording pressure gauge reading from the gauge at each increment. Then remove the weight and record gauge reading. By working out theoretical result, they can work out gauge error and discuss possible cause. So equation 1 we have P actual and equation 2 is to calculate the force and equation 3 is to calculate the percentage error. This is the experiment setup.
For the methodology part, number one, the apparatus was set up as figure 2. Number two, the cross-sectional area of the piston was recorded. Number three, oil was poured into the cylinder until it overflows, and the reading of gauge was ensured to be zero. Number four, the piston was carefully placed back into the cylinder to reduce friction effect upon putting on weight. Number five, air bubble trapped inside the cylinder and tube were removed by gently tap and rotated the tube. Number six, the gauge pressure was measured and recorded as the first reading. Number 7, 0.5 kilogram of weight was added into the piston surface. Number 8, the reading of pressure gauge was measured and recorded after system was stabilized. Number 9, step 6 and 7 was repeated by adding 0.5 kilogram of weight at interval until the total mass reached 3.5 kilogram. After that, 0.5 kilogram weight was removed from the piston at interval until it reached the total mass of 1 kilogram. And then the reading of pressure gauge was measured and recorded after the system was stabilized. Number 12, the step 9 and 10 was repeated until all the dead weights are removed. And number 13, step 4 until 11 was repeated for another 2 times, and the average pressure gauge reading will be recorded.
Result raw data for actual pressure and experiment gauge pressure with percentage error. At this page shows the table 1 which shows how we calculate the actual pressure and the result of actual pressure in the table. So in this case, we are using equation 1 and 2 to calculate the pressure. So first of all, equation 2 is to calculate the force, and we use mass multiplied by gravity constants to get the weight is known as force, and then we divide by area. So fixed area, the area is fixed in this case for the cylinder tube, which is 0.003 1731. So we get the actual pressure, and we can see that the more the weight increase, the higher the pressure. So the highest pressure we get is 108 kilopascal, whereas the lowest pressure is 30.9. So this table 2 is the calculation of percentage error between the actual pressure and experiment gauge pressure. So in this case, gauge pressure we measure in two ways, which is loading and unloading. Loading means that we keep adding the weight on the piston, whereas unloading is we remove the weight from the piston at zero point 0.5 interval. Okay, and the larger the percentage error shows that the value difference between actual and experiment gauge are larger. So the highest percentage error for loading is 30.9, whereas for unloading is 28.84. The lowest percentage error for loading and unloading have the same value, which is 45%.
Based on the figure 1 and 2 for the percentage error of both loading and unloading, we can see that the highest error is at the initial, which is 1 kg, and it starts to result at 1.5 kg. And for the figure 3, it shows that the gap between the loading and unloading absolute error is increasing as the base increase. The highest error for figure 3 is at 1 kg, which is 9.58, and the lowest is at 2 kg, which is 0.83. Based on the percentage error from the experiment, we get the value of the average percentage is 12.79.
For the next discussion is about source of error and method to minimize the error. The first one is reading error. Human error can occur when the observer misinterprets the position of the needle on the scale, especially if the gauge markings are close together or not clearly visible. Small mistake in reading the scale can lead to cumulative error in the calibration data. Method to minimize the error is align eyes with directly in front of the gauge needle at perpendicular angle to the scale. This prevents parallax error which occur when the gauge is viewed from an angle and can lead to misinterpretation of the needle position. For the next source of error is air bubbles in the cylinder tube. Air bubble trapped in the cylinder tube can compress when pressure is applied, leading to inaccurate reading. Since air compresses more than the hydraulic fluid, it can create inconsistency in how pressure is transmitted to the Bourdon tube, which can delay the gauge response. How to method minimize is carefully bleed the system before starting the experiment by opening a valve or loosening fitting at the highest point in the setup. Tapping the cylinder tube during filling the system with a fluid that can help dislodge bubble that might otherwise remain trapped.
For repeatability and accuracy of this equation, we are referring to the three absolute error for loading and unloading. Based on the table above, we repeat the experiment for 3 times for every mass. And for all the mass, we can see that for every repeated experiment, we get quite consistent value. For example, for mass 1.5 kg, the loading gauge pressure reading for experiment 1 is 40 and experiment 2 and 3 are both 39. Meanwhile, for the unloading, the same mass, 1.5 kg, all experiment 1, 2 and 3, we get the gauge pressure reading 40. We can say that this experiment has a good accuracy as the reading of the gauge pressure nearly the same. For instance, for mass 1 kg, the average pressure is 59, while the actual pressure is 61.83.
For the safety
For the
procedure,
safety
kindly
procedure, the first one we must
check
Bourdon
the
gauge, the
Bourdon
weight
gauge
tester and the
so that
piston for
we
any damage
can
or leak
prevent
before
any
starting the
damage and
experiment
or
to avoid
leaks
accident.
of
And then
oil
we must
before we
wear
start
safety
the
goggles and gloves to
experiment to
protect the
avoid
eyes and hands when
accidents.
working with the
Besides, we
pressurized
need to wear
equipment.
safety
Then third one,
goggles and
handle with
gloves to protect our
carefully
eyes
to
when
avoid
working with
dropping them, which can
pressure
cause injury or
equipment,
damaging the
and
equipment.
handle the
And
weight
then do
carefully
not
to
exceed the
avoid dropping
maximum
them.
pressure
And
rating
then
of the
we
gauge
need
or
to
excessive
do not
weight, as
exceed the
this could
maximum
cause
pressure,
equipment failure
and
or
we
injury. The last
need
one, when
to
finished
release
the
the pressure
experiment, release
slowly
the
to
pressure
prevent
slowly to
sudden pressure
prevent sudden
change.
pressure change, which
For
could
the
damage
safety
the gauge
procedure,
or tester.
kindly check all
In conclusion, this Bourdon tube pressure gauge equipment applied the pressure transmissibility principle. And the data collected shows that it have a good accuracy and precision reading. It have a slightly higher percentage error in the beginning, and as the math increase, the percentage error of the reading decreases. We find the average percentage of this for the gauge to be 12.79%.
This is our reference. This is the Excel link for calculation. Thank you.